gang, welcome to week 5 of Code Club. By this point, if you've watched all the previous videos, you should have all the building blocks you need to make whatever you want in Scratch. So this week, Alice and I are going to show you some things to make your life as a Scratch coder easier, like variable scopes, sprite rotation styles, and how to use Scratch's image editing tools. Open up another browser window and log into Scratch so that you can follow along. Have fun and let's start coding. I don't know if you've ever noticed this before, but when you create a variable in Scratch, you have two choices here for all sprites or for this sprite only. And what that does is set what's called the scope of the variable. And the default is for all sprites, which means it's going to have global scope. And global scope means that every sprite and your backdrop is going to be able to see the variable or set the variable. If you set it for this sprite only, that means only the current sprite that you're on, so right now I'm on this Abby sprite, only the Abby sprite would be able to see that variable. Why would you want to have a variable with for this sprite only or local scope? Well, let's say you're programming a game where you have a character who's running and you have a monster chasing your character. Well, both of those things are going to need a speed variable to control how fast they're running. And you want the speeds to be different. You don't want your monster and your character to run at the same speed because the monster would never be able to catch your character. So if you have two different variables called speed that are both for this sprite only, then each of them can have a different speed as your program continues. When you create a variable in your backdrop, those are always going to be set to for all sprites. There's no way to create a variable that's local to just your backdrop. I've got a little example set up here to show you what the difference is between global and local variables. If you look here, I have, for sprite 1, I have a global variable called global1 and a local variable called local1. In sprite 2, I have the same thing. And in sprite 3, I also have this. And you can tell that the local one variables are local because if I look in the backdrop, I only see one variable called global. And on each of these sprites, I have code where it sets the global variable to the sprite name and the local variable to the sprite name. And then it says what the result of that is. And then on sprite 1, I have it reset the global variable and the local variable and say what that is. On the other two sprites, it sets it to the sprite name for the first one, and then on the second one, it just waits a second or half a second so that it can say what the result is after sprite 1 changes the thing so that you can see what the difference is. If I run this, you'll see, so they all right now say they're local names. So sprite 1 local, sprite 1 local, sprite 2 local, sprite 2, sprite 3, sprite 3. Now if we give it a second here, it's going to reset. So now this one says reset in sprite 1, reset in sprite 1. This one says global is reset in sprite 1, but the local is still sprite 2 because changing it in sprite 1 doesn't change it in sprite 2. And then the same thing with sprite 3. It gets reset. The global is still reset in sprite 1, and local is still set to sprite 3 because that local variable doesn't carry over to the other two. The other place where local versus global variables comes into play is when you're using clones. Anytime you reset a local variable in the when I start as a clone hat for a script, it's going to reset that local variable for only the current clone. That change isn't going to affect any of the other clones. I set up a little example here to show this. Basically, when the green arrow flag is clicked, it will set a random number into the local random number variable, and it'll set a random number into the global random number variable. Then over when it starts as a clone, it's just going to say the local and global random numbers. And what's going to happen is you'll see for the two clones that I create, those two local and global variables are going to be the same for both clones. Then I'm going to reset the local random number to a new number, and they should both be different now for the two clones. So let's see what happens. So here's the first time through. They both have 5 and 9 for their local and global variables. Now it reset them. Now the local variable for this sprite is 9. The global variable is 8. So you see it reset that local variable to a different random number for both of the clones. If you've been paying attention, you'll see that there's another option in the new variable screen, and that is cloud variable stored on server. And basically what that means is it lets you store a variable out on Scratch's server, and every time you start up your program, it will read that variable off the server, and every time you change it in your program, it will push that new data back up to the server. I'm not going to go into an example of this because you guys might not be able to use it yet. You have to be a certain level of Scratch user in order to be able to use it. And it's kind of limited. You can only store numbers in it. You can only use 10 cloud variables in a project. It would probably be good for keeping things like a high score or how many people have viewed your projects and things like that. But because it's kind of limited and you might not be able to use it yet, I'm just not going to go into how to use it. As you've been watching the videos, you probably notice once in a while I'll click on the little checkboxes here next to your variable names or next to a list name. And what those do is they turn on a display over in the main Scratch window that lets you see what the contents of that variable is. So right now, I don't have any code to set any of them, so they're all set to 0 in an empty list. But if I were to add, a set local 1, 2, whatever that is, and I run that code, it updates over here so that you can see it. One thing you'll notice as you look at these is this is a global variable, so it doesn't say anything in front of it. This one is a local variable that's local just to sprite1, so it says sprite1 local1. This one is a cloud variable, so it's got a little cloud in front of it. And then this one's a list, so it looks completely different because it's set up to have list items in it. In addition to turning variables on and off using the checkboxes, there's also code you can use that say, show list, and then you can choose a list, or hide list. And then the same with variables, you can say show variable or hide variable. When you have a variable showing, there's actually several different options for how it looks on the screen when it's there. So this is the normal readout. It shows you, if it's a local variable, it shows you the sprite name, it shows you the variable name, and it shows you the value. If you change it, and that's called normal readout, if you change it to large readout, that shows you just the value that's stored in the variable. If you change it to slider, if your variable holds a number, this lets you use a slider to move it up and down and change the value of it. If you want to use the slider option on your variable, you can right click on it and do set slider min and max. So if you want your user to only be able to choose between 10 and 20 in your slider, you can set the min and max range for that. So now, if you look, the minimum here is 10. When I move it over, when I move over that slider, it only allows it to go up to 20. So you can let the user only choose a certain amount of things in your, a certain amount of values in your script. For lists, you can actually add and remove things from your list based on the box that gets shown. So if you click this little plus sign down in the corner, that lets you add things. Thing 1 and thing 2. And when you have things in your list, if you click on them, it lets you edit them, or you can click the little X to delete them. The other thing you can do with lists is you can import and export data from a text file into your list or out of your list. So right now I have list 1 that has thing 1, thing 2, thing 3, all the way up to 6, and it's the only list I have right now. So if I right click and go to export, it pops up a little box. You can't see it on the screen, but it pops up a box, asks me a file name. I'm going to save it as list1.txt. Now if I create a new list, and I'll call it list 2, and I right click on this, and I do import, and again I'm choosing a file that you can't see, but it says it's the file list1 that I just exported. It imports all of those things into list 2, so I don't have to retype them all. You could also use this if you have a list of something, you want to create a game with a bunch of usernames in it or something like that. You can make a list with 100 usernames in it and import them all at the same time instead of having to type them all at once, or type them all by hand. So if importing a list is something you want to do, all you have to do is create a file that in like Notepad or whatever on your computer, and each thing you want on your list just is a new line in the file. A good example of where you might want to use showing your variables in your script is if you have a game where you have a difficulty setting. So on my ping pong game, I let you choose the difficulty, and it's a range between 1 and 15, and it defaults to 7. And you can move it up and down, and that sets how fast the ball moves, basically. So, and I use some of those show and hide variable things that say, so for the difficulty setting, I say show variable difficulty when this is clicked. When the spacebar is clicked, that starts the game, so I hide the difficulty variable. In a sprite, when we want it to rotate, we have a couple of different options for how it looks when it rotates. And they're called rotation styles. There's 3 options: all around, left, right, or don't rotate. And that's what these 3 little icons here mean. We pretty much have always been using all around so far, but I can show you what the difference is between all of them. So the first example I'm going to show you is all around, which is what we've been using. When we change the direction of the sprite, Scratchcat is going to point in the direction that we do it. So here's my script. I'm going to have an all-around rotation tile, then point 90 degrees, which is over to the right, then move 100 steps, which is going to make him move over to the right. Then we'll point him minus 90 degrees, which is going to move him over to the left and make him point to the left. Then we're going to do 0, which is going to point him up and have him move 100 steps up. And then we'll point him 180, which will point him down and make him walk down. So if you watch real quick, it's going to run the script and do that. So first one, he moves to the right. Second one, he moves to the left and points to the left. Third one, he points up. The last one, he points down. It's exactly what we thought was going to happen with the all-around rotation style. So he moves and the costume points in the same direction. The next example I'm going to show you is left-right. And what left-right means is the direction of the costume is only ever going to change to the left or to the right. It'll never change up or down. But Scratchcat is still going to move whatever direction we say. So, we say point in direction 90, he's going to move right. We say minus 90, he's going to move left. We say 0, he's going to move up. We say 180, he's going to move down. For the costume changes, though, if it's between basically 1 and 180 for your point in direction, he is going to not change direction. If it's between 0 and minus 180, then he's going to mirror himself on the y-axis, which means he's going to basically flip himself over to the other side, left or right. So if we do this change here, change it from all around to left-right, what's going to happen is he's going to point 90 and move. So he's going to move the 100 steps over to the right. He's going to point minus 90, which means he will flip because that's between 0 and minus 180. So his picture will flip and he'll move in that direction. When we change it to 0, that's going to flip him back the other direction. But because it's 0 and that's up, he's going to move up. And then for 180, that is a don't do anything choice. So he's not going to flip, but he's still going to move down 100 steps. So let's run it, make sure it does what we think. So he moves to the right and is pointed right, moves to the left and is pointed left. He moves up and points back, and now he moves down, but is pointed the same direction because 180 doesn't make it change in the left-right. The last option is don't rotate, and what don't rotate means is the costume is never going to change direction, but when Scratchcat moves, he's still going to point in whatever direction that we think he should, and move in that direction. So none of these point in directions will change which way Scratchcat, the costume, is facing, but it will make him move predictably how we think he should. 90 will make him move right, minus 90 will make him move left, 0 will make him move up, 180 will make him move down. So run this real quick, we can see he moves right but doesn't change direction. He moves left but doesn't change direction. He moves up but doesn't change direction. And then moves down but doesn't change direction. One other thing that's annoying in Scratch is when you have to use set pen color 2, you have to click in there to select the color, and then you have to find something on your screen that's kind of the same color as what you're looking for. So, I want the same color as this blue in C project page. I have to kind of find the right spot in here where it looks right and click on it in order for it to be in that box. And then it gets really more annoying when you want to do comparisons between two colors. So if I want to say touching color or color is touching, I have to do that same thing. I have to select here and then I have to go find that same blue up in this thing. It just is really hard to do. The cool thing is that Scratch lets you set that pen color to be this equation instead of having to select something off of your screen. And what that equation does is sets the color to a number that you can look up on the internet. And so there's 4 variables in here. There's alpha, red, green, and blue. And any of these variables can be set between 0 and 255. And if it's 0, that means it's off. If it's 255, that means it's all the way on. The red, green, and blue variables do exactly what you'd think they'd do. They set how much red, how much green, and how much blue is in your color. And the alpha variable sets how transparent your color is, which means how much you can see it. If it's set to 0, that means your color is turned all the way off. You're not able to see it. If it's set to 255, it's turned all the way on, and you'll be able to see your color. If it's somewhere in the middle there, then it's going to be some sort of transparent where you'll be able to see behind the color a little bit because it'll filter through the transparency. Like I said, you can look up your red, green, and blue values on websites on the internet. And here's one right here. I'll share it out with you guys as part of the video. And so let's say I wanted my Scratchcat to draw a deep pink. Well, right here are the red, green, and blue values that I need to use. It's 255 red, 20 green, 147 blue. So let me type those in. Red 255, green 20, blue 147. Now when Scratchcat draws, it draws in hot pink. And I have my alpha, my transparency, set to 100, so it's kind of transparent. If I reset this back up to 255, it's going to be not transparent at all. Now it's that deep pink that we were looking for. If I set it down to something really low like 10, it's going to be really transparent, almost to the point where you can't see it. If you look in the comments for this video, you should see a link to the Scratch project that has this equation in it, and a link to this color codes chart so that you can start using the equation in your programs to set the colors instead of having to choose it manually.
Scratch has built-in tools that let you create and edit images to use in sprite costumes or backdrops. To create a new sprite, you click the paintbrush icon in the sprites area. To create a new costume, you click the paintbrush icon in the costumes area. To create a new backdrop, you click the paintbrush icon in the backdrops area. To edit an existing costume, go to the Costumes tab and select the costume you want to edit. To edit an existing backdrop, just go to the Backdrops tab and select the backdrop you want to edit. Once you are in the editor, at the bottom of the screen, there are options for bitmap mode or vector mode. Vector makes your drawings less blocky or pixelated and makes them so they won't get more pixelated if you zoom in on them. Bitmap mode will create pictures that are more pixelized and will get pixelized when you zoom. Unless you are editing an imported picture, you will pretty much always want to use vector mode. If you convert a picture to bitmap mode, then back to vector mode, it will be pixelized. There is no way to fix that. There are a lot of buttons that are similar whether you're in vector or bitmap mode. At the bottom of the screen, there are plus, equal, and minus sign to zoom in and out and to set back to the standard zoom. So if I wanted to zoom in on my beetle, I'd click the zoom in button. If I wanted to zoom back out, I would hit the zoom out button. And if I wanted to reset it back to the one it was originally at, I would hit the equal button. When you are editing a sprite or costume, one of the things you can do is set a costume center. This is the button that you would use. This changes the center of the sprite when it moves and rotates. For example, I have this bug centered at X0 and Y0. If I change the center to this leg, instead of the middle of the bug, it moves the sprite's middle to the new center that I just shows. When you rotate a sprite, it rotates around the costume center. So, for example, the bug, he rotates around his stomach like this. If we change the center to be on the back leg, it will rotate around the back leg instead of the stomach. You can also flip the current picture on either the x-axis, up and down, or the y-axis, left and right. You can undo or redo changes that you have made. Or you can clear the entire image. You can add a pre-built costume or backdrop from the scratch gallery. Or you can import an image from your desktop using the import button. We aren't going to show this, but it works just like uploading a sprite or backdrop. At the bottom of the screen, you can select a color for whatever tool you are using, and this is how you select them. You click on them. One of the color options looks like a red slash. This means no color. If you want to select a color that already exists in the image, you can use the eyedropper tool. If the set colors in the list don't contain what you want, you can also change to the advanced color picker, which lets you choose from a wider range of colors. You can also change the transparency. The color editor also lets you set two active colors and switch between them if you have two colors you're using a lot. You switch them like this. One last tool that is the same between vector and bitmap is the line width tool. It lets you choose how thick the lines you're drawing are. There's one thick one. Here's a thin one. First, I'm going to show you how to use the vector editor. When you are editing in vector, everything that gets added is considered a shape. You can draw with the pencil. You can draw lines. These will be straight lines. You can draw a rectangle. The rectangle tool can also be used to draw a square by holding down the Shift key while drawing. With the filled and not filled buttons at the bottom of the screen, you can choose whether your rectangle is filled or not. You can draw a circular shape with the ellipse tool. You can force the ellipse tool to be a perfect circle by holding down the Shift key while drawing. The filled or not filled buttons also apply to circles. The selection tool lets you select the shape. You can select them by clicking on them. You can also select multiple items by holding down the Shift key while selecting. Once you have a shape selected, you can move the shape around, Or you can delete the shape by clicking on the delete button on your keyboard. Or you can resize or rotate the shape by dragging on the dots around the side of the shape. Look at this. You can add text to your costume with the text tool. This is the button you would push. When you are editing text, you can also change the font of the text. Once you have shapes in your editor, you can fill them with the fill tool. If you want to make sure you're filling in the right place, it will highlight the area that is going to be filled. You can also duplicate existing shapes with the duplicate tool. When you have multiple shapes on your costume that are overlapping each other, you can set what is front and viewable and what is behind so that you can't see it with the forward a layer and backward a layer buttons. If you hit Shift while using these buttons, it will bring the selected shape all the way to the front or send it all the way to the back. If you have multiple shapes selected, you can group them together to be treated as one shape with the group button. This lets you do things like resize or change layers for the entire group of shapes. If you have a group selected, you can ungroup it for individual editing by using the Ungroup button. Because everything in Vector is a shape, you can use the Reshape tool to move the lines to make the shapes look different. Select the Reshape tool. It's this one. Then select a shape. It will add several dots that you can drag around. Like this. You can also click at any random place in the image and it will add a new dot to drag around. In the bitmap editor, most of the main tools like the brush, line, rectangle, and circle work basically the same, so we won't show those. For the fill tool, there is one big difference in bitmap mode. You can fill a background in bitmap, but not a background in vector because the fill has to be inside a shape. There are several newer different tools in the bitmap editor. The erase tool lets you erase parts of your image. In vector editor, you have to select a shape to delete parts of the image. In the bitmap editor, you have to erase the part you don't want. The selection tool lets you select whatever part of the image you want, not just selecting one or multiple shapes. The duplication works different too. You need to select a square area of the image to duplicate. The remove background tool lets you select part of your image by drawing around it. Then it will remove everything else from your image. If you draw a shape and then click somewhere else in the window to make it work. The crop tool will let you select a part of your image, then delete everything that isn't in the selection. That should be everything you need to know about how to edit images directly in Scratch.
Alright, that's it for week 5. I hope you enjoyed it. Now go do some coding on your own. Have fun, be creative, and we'll see you next week.